Okay, as we continue our unit on expressions, equations, and functions, we're going to get to the functions part today. We're going to discuss what is a function and then also how to write a function as a rule and also how functions are listed in the table. So you're probably familiar with the function machine. A value goes in as the input and an operation is done, a rule is performed, and you get your output, your new value. So there must be a rule in there. We're going to talk about the rules and then how it looks like as a table. Let's just get the concept down first of what is a function. So let's just pretend we're all here in class, and I've got 4 letters up on the board. If you're in 8th grade, you'd come up and stand under letter A. If you're in 9th grade, you'd stand under B. 10th grade, you'd be under C, and any other grade, you'd be under letter D. What would you notice? Well, each person in the class would have a letter that they would be standing under, and each person would be only under one letter. If you're in 9th grade, you're not also in 10th grade. You can't be in more than one grade at a time, but each of the grades would be covered. Okay, now let's take a look at the clothes example. You can see the descriptions there. If you look at what you're wearing, what color shirt that you're wearing, notice I'm wearing black, so I'd go stand under letter C. But you can take a look at that, and maybe you're wondering, well, the color that I'm wearing isn't listed under there, so what do I do? Or maybe you've got a multicolored shirt like Joseph, and you don't know which one to stand under. So there becomes a problem here. Okay, the relationship between the color of the clothes that you're wearing doesn't fit now, as it worked with the classes. Each person had a specific class. Birthday. You can see the scenario there. And maybe you're wondering, well, my birthday month isn't listed there, so what do I do? So, in that case, the rule doesn't work. So for clothes and birthday, the rule doesn't work. There's not a specific rule because there are multiple options there. Whereas the class, there's a rule. If you're in a certain grade, you stand under the certain letters. That's what makes a relationship between two variables a function. And we can list that rule that we have there. A function consists of, we have a set of two sets of numbers, the domain, which we call the inputs in our function machine, and the range, which we call the outputs. Okay, so many different new terminologies that we'll use. So domain is the input, range is the output. We need the inputs when we pair them with the outputs. That's a relation, but it becomes a function, and here's the important part, when each input is paired with exactly one output. So that's important to keep in mind. Each input has to have exactly one output. When we're talking about the clothes, you might have had multiple outputs. I'm wearing black and red. Or maybe your color wasn't listed on there, so I didn't have an output. Same with the birthdays. Well, if I had a January birthday, I wasn't with the February group, but maybe my birthday wasn't listed, so it's not a function. It doesn't follow for all the numbers in the domain. Okay. We can take a look at this table here and show why this is a function. The inputs, this is talking about you're pumping gas at the gas station. We've got 10 gallons, I get $26.59. 12, I get $31.91. 13, it costs $34.57. 17 is $45.20. So each input has exactly one output. When I go to the gas station, I expect if I am paying $2.65 a gallon, that's the cost that I'm going to get with 10 gallons each and every time I go. So here my domain is going to be all of my input values. So my domain would be 10, 12, 13, and 17 in this case. And the range would be these output values. Okay, So let's take a look at how we can identify whether a relation is a function. One way we can do that is by looking at the table. We can make what's known as a mapping diagram, where if we know that these are the inputs, so we've got a 2 as an input, and when I put 2 into the function machine, I get 2 as an output. I also get 4 as an output. When I put 3 in, I get 6. Put 4 in, I get 8. It appears that the majority of the time my input doubles, except for the case with 2, when it doubles, but it also stayed the same. So the rule doesn't always follow. So here is the error. 2 goes to 4, and it also goes to 2. It has multiple outputs. Okay, so it's not a function. Okay, so look at the second table. Input of 4 goes to 12, 8 goes to 12, 9 goes to 25, and 15 goes to 45. You want to do a mapping diagram, I can say, well, 4 goes to 12, 8 also goes to 12, 9 to 25, 15 to 45. So is this a rule? Is this true? Does each input have exactly one output? It appears that each time I put a value in, it gets an output. So yes, that would be a function. Okay, so this is a function. You know, even though you might think, well, 4 and 8 both have the same output, that's okay, as long as they have exactly one. That's good. I guess I can't spell here. Oh well. Come on. Okay. We'll move along. Next, we have that set of inputs and outputs. What do you think? Is that a function according to the table? Well, each input has exactly one output. So we would have to agree that yes, that is a function. Now, some more terminology that we want to keep in mind as we're talking about functions. We talked about the domain and range. Domain was the input, range was the output. Another way that it's referred to as the input is also called the independent variable. As you start to do experiments, especially in science, we refer to these as the independent variable. And we refer to the range or the output variable as the dependent variable. Okay, because it depends on what we put in to the function. So as we think of that function machine, this input variable, we put whatever we want in here, it's independent, and whatever the rule is that acts on the function, we get an output, which depends on whatever we put in. So if this is the verbal rule, the output is 5 more than the input, I can list an equation there. Well, y is equal to x plus 5. So most often we're going to use our input variable, our domain, as our x value. Our output will be our y value, our range. So let's just come up with a list of inputs. Let's say this is 0, 1, 2, 3, and 4. So our domain is 0, 1, 2, 3, and 4. And if we put a 0 in, we're just substituting the expression. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. And 4 plus 5 is 9. So our range in this case would be 5, 6, 7, 8, and 9. Okay? So go ahead and try that next example there. Our domain is going to be 4, 6, 9, 11, and 12. So our domain, once again, is our x values, our input. So if you put those values in for your inputs, go ahead and see what you will get. You want to pause the video and see if you can get see what values you can get on. Okay, so taking a look at this function, when we follow the rule half of x plus 3, We put in these values for our domain. This is what we get for our range. Okay. Now let's come up with a rule for our functions. Okay, if we have our table given to us, let's come up with a rule. Oops. So remember, our input is our x value. Our output is our y value. Our input is our independent variable. We're putting that value in and we get, put 1 in, we get 0. 2 in, we get 1. 4, we get 3. Put 7 in, we get 6. Put 9 in, we get 8. So what is the rule? How do we get y? What do we do to x to get y? Well, I can see that the numbers are decreasing by 1. So my x values decrease by 1. That's the same as my y value. Okay? Why don't you try the next example there. Pause the video and see if you can get the rule for that one. So as you can see there, as I go from the input to the output, the numbers are doubling. So my output, those values are equal to double whatever the input was. So my output is equal to twice my input. Okay, we can do the same thing if there's a graph. Oftentimes when we're given a graph, it's helpful to take a look at the table. And now I'm going to write my table vertically. I prefer that to the horizontal tables, but you can decide however you prefer to write it. So I'm just going to list my coordinates. So over 1 up 0, over 2 up 2, over 3 up 4, and final point is 4, 6. Okay, so our rule, we want to find out how do we get y. Well, what is y equal to? Well, take a look at what happens to y as we go from x. What do I have to do to x to get it equal to y? Well, we notice that it's not just subtracting 1 because that doesn't hold up. We know that it's not just multiplying by a value, so we have to combine the two. So notice in this case, if I take my value and I double it, so 1 times 2 is 2, how do I get to 0? I have to subtract 2. Does that work for all the other values? It must work for everyone. 2 times 2 is 4, minus 2 is 2. 3 times 2, 6, minus 2 is 4. If I double 4, I get 8. Subtract 2, I get 6. So that's the rule that works for every situation there. What is my domain? Remember, the domain is every one of the independent variables, or the inputs. All these x values here. So my domain is 1, 2, 3, and 4. Okay, which leaves the range as the dependent variables 0, 2, 4, and 6. Okay, let's try that next one on your own there. Okay, did you get a chance to try that out? I made a table first listing all the corresponding inputs and outputs. And with these, you'll have to do a little bit of trial and error. Notice that if I go from 0 to 1, that's increasing by 1. That rule doesn't follow here. And the same thing, if I go from 2 to 2, I would think, well, maybe I just multiply by 1, but the rule doesn't follow. So you have to, combine different operations and see what you get. And I found the rule is if I take x and divide it by 2, and then I add 1, that will give me my y value. Which leaves my domains as 0, 1, 2, and 3. The range, my outputs are 1, 1.5, 2, and 2.5. Notice the values as I'm going up the y-axis, 1, 1.5, 2, 2.5. Domains are the x values, 0, 1, 2, and 3 as I go along the x-axis. So today we learned what a function is, that it has exactly, or each input has exactly one output. We found out how to take a look at those on a table, and compare and see each input has to go to exactly one output. And we also learned how to write a rule from the table as well. You have some practice problems to do. As always, do those. If you have questions, we'll take a look at those in class.